Today in our webinar, an overview of AI applications, we are going to talk about how AI has gained a lot of momentum in past few years. It has already having a great impact on how we live and work. But this webinar will give you a brief introduction, a high-level understanding of artificial intelligence and machine learning applications, and how these are used in some practical ways in enterprises. As an AI enthusiast, you would understand how end-to-end AI applications are built for large enterprises and businesses, and looking to uncover opportunities to begin with AI and ML projects. In this webinar, we will be talking about the key innovation and applications using AI and ML in enterprise deployment. Also, what are the trade-offs that needs to be considered to deploy AI applications in real time? With our luck, we have a very esteemed instructor today for the webinar. Let me introduce Majid Bemanian, sir. He has a high-tech industry experience with broad hands-on engineering, marketing, and business management skills in the areas of ML, AI, device security, cloud computing, embedded systems, entertainment technology, HPC, and networking. He has worked with various companies in Silicon Valley, like Wave Computing, MIPS Tech, Imagine Tech, Applied Micro, LSI Logic, and several early-stage startups. He's a top-performing business development and marketing executive with strong business and product planning, corporate strategies, managerial and sales expertise. He has 10 patents on his name till date in various fields, and also he has led acquisition of several companies. It is a great honor to receive and understand about AI from you, Majid sir. Let me introduce to our founder and another speaker today, Bhushan Muthian. He is a core founder of Sentiligent Academy. He's a data scientist professional himself, who is very keen on applying algorithmic models to his business challenges by making cutting-edge artificial intelligence accessible to all. He's a graduate from San Jose State University with MS in ML and embedded systems. He has an industry experience to generate breakthrough ideas and commercialize innovation and growth solutions on a global scale. In fact, Bhushan sir and Majid sir used to work together at Wave Computing on AI applications. So I will give the stage to Bhushan sir. Can you please talk a little about Sentiligent Academy, and then we will start our webinar with Majid sir. Thank you.
Thank you, Rutuja. Hello, everyone. I would just like to give you a small overview, as Rutuja has given a very nice overview about Majid and myself. Would like to take this opportunity to thank you all to be participant for this webinar. There are a lot of efforts from different colleges, especially from AI, SSMS, and other colleges as well. So thank you everyone, whoever are attending this webinar. This is one of the webinars in our webinar series in artificial intelligence. Would like to talk about why, what is the reason behind the Sentiligent Academy. One major reason behind Sentiligent Academy to start with, Majid can correct me if I'm wrong. The vision of creating an AI applications is very important. Product-based industries in terms of artificial intelligence is very rare. So this is this vision we have started about Sentiligent Academy is to focus more on application oriented programming, wherein cutting edge artificial intelligence, machine learning, and deep learning will be utilized for in the near future to develop products in healthcare, retail analytics, autonomous cars, and other. Yeah, please go ahead.
Okay, good. Thank you so much, Rutuja and Bhushan, for the introduction. And thank you for inviting me to this webinar. Really appreciate it. As part of the agenda, we did cover the introduction, and we'll just go ahead and jump into some of the reasons we actually choose to go into the cloud versus the edge, and why AI is critical for those areas. So then I will jump into the high-level understanding of artificial intelligence and focus mainly on cameras. I think that's a critical part of our life going forward. And based on that, look at some of the trade-offs that need to be considered. And the intent here is it's not a one-size-fit-all. That's one of the challenges that a lot of folks run into is the fact that AI is not necessarily one-size-fit-all, and part of that has to do with the fact that there is a lot of computation required, and to mimic the human intelligence, it's just not possible to replicate that with one type of capability. So we are going to see a lot of different solutions out there, and as I mentioned, it won't be a one size fit all. So that's what we should keep in mind as we keep going through this era. This particular slide is actually provided by Sean, who's worked on this a lot. But the intent is to demonstrate that, as I mentioned, it's not a one size fit all. There is so many different areas that today people are working on, and it is critical for the folks to understand those decisions that are made at every level of deployment of a product, or you would be challenged with I wouldn't say failure, but not necessarily meet the market requirements that you guys are targeting. For example, in the case of a smart speaker, whether it's a Siri type or Alexa or others, the technology that's used there is by far drastically different than the technology that's used in autonomous vehicle. And what's used in an autonomous vehicle will be very different than what's in the retail analytics or for a surveillance camera. For example, in an autonomous car, you have going forward for a new cars that are coming out, as many as 12 cameras. These 12 cameras are going to be high resolution cameras, anywhere from 8 to 12 cameras, plus radar and LiDAR. But the cameras generally will have to sample at 60 frames a second. You're probably driving anywhere from 60 kilometers to over 100 kilometers. And with that, you have to detect tens of objects. So the complexity of classifying the objects for an autonomous vehicle is enormous. But at the same time, you can't consume a lot of computation on that. So a lot of innovation has to go into autonomous vehicle, where it's moving at 60 miles an hour and trying to classify images. On the other hand, a surveillance camera would require, anywhere 5 to 10 classifications a second, and it's stationary. So the complexities are very different. Some require mission critical, like autonomous vehicle, a drone, or others, that accuracy has to be high. In some cases, we have to do redundancy. So redundancy becomes critical. Safety is an issue, security is an issue, and other means. So as I mentioned earlier, it's not a one size fit all, and that's a critical consideration or something that you need to keep in mind when you're designing your platforms for your next generation. Here, there are other use cases. Again, it varies from health to retail to construction. Of course, the applications are limitless, and many areas of interest today, a lot of deployment. But again, we are at the infancy of AI. And this is an excellent opportunity for, as Bhushan mentioned, for anybody in the world to take leadership and utilize their domain knowledge to build products that solve a lot of these problems. And it's all about innovation at this point. Why is it that all of a sudden artificial intelligence is working for us, right? The diagram on the right is quite familiar to everyone. We got the artificial intelligence, machine learning, and deep learning as a subset of. It's such a fucking hole. I love it. All right. So why is artificial intelligence is basically one of the main thing is that machines have selectively surpassed human intelligence in both accuracy and speed. Now, I say selectively, you have to consider that it's not in every area where that is happening, where it comes to accuracy and speed, but clearly machines have reached that point. They can learn, predict, and classify to some level, reason and plan and perceive, but clearly they're able to have ability to learn and classify very effectively. Compute density and algorithm efficiencies are within reach. Now, there are two words here that are very important to note. I talk about compute density and algorithm efficiency. So there is enough compute today that to solve a lot of problems, but is that dense enough to address your specific application? Right, that's very important to note. A smart speaker would require microwatts, where an automotive could be kilowatts or close or in hundreds of watts. So there is a drastic difference in what level of compute you can apply to those. Algorithm efficiency is also within reach, but not necessarily you're there. There is a ton of innovation that's happening in the compute density and algorithm efficiencies that is helping the machines reach the point that they can do more with less. And that's, we're not quite yet there, especially when it comes to the edge. The other reason that we are actually seeing the takeoff for artificial intelligence is because of the large set of the data sets that are available, but either structured or unstructured, that is available for training and learning, and those data are important, and having to understand what's available is definitely very, very important, for the application developer. And also, finally, as humans are by default love comfort, the demand for make that comfort at a price is there. So there is a lot of push to make our life more comfortable by applying artificial intelligence to solving some of our problems. There is a lot of debate around if that's really the case or not, but the fact that humans make mistakes and errors, and machines that can actually be more accurate in those areas are also reason for the strong demand for them. The other thing that's important to note is that a lot of software developers, when it comes to AI, they look at the application level, a little bit of the libraries for the algorithm, but generally what goes underneath, like the operating system, examined. And I'm going to take you guys through some of those because I think it's very critical as you guys look into solving these problems, to consider all the details about the other two areas, the operating system and the hardware as well, when you're looking at solving your AI problems. As we see, generally, how is AI evolving? You can almost run any type of algorithms today on an Intel or AMD processor because they're generic, and they have enough storage, memory, and scalability to kind of almost address any type of algorithm, any size, a complexity of algorithm. However, you may not be able to reach the classification rate that you're looking for. In some cases, it may be sufficient, but it is a good platform for development, maybe for learning or other means. But in general, as robust as the Intel, for example, solution or AMD brings in, you may not get throughput. But what folks would do is, of course, complement their CPU or the server with maybe a GPU from NVIDIA or similar. In that scenario, when GPUs are more tailored around algorithm processing, they can get to acceleration necessary for a lot of these applications. And of course, the GPUs have a long history of working very closely with the CPU, so it makes it much easier to integrate into your application. And there's a lot of libraries available, so you can easily, for example, from a Python, specify the libraries map into a GPU, and you can get the boost necessary. But in a lot of cases, even a GPU together with a high performance Intel CPU may not meet the target performance that you're looking for. And that is true many of the applications that are being developed today. So engineers and architects turn into more customized way of running these algorithms, like for example, Google TPU, or a lot of other folks that are out there that developing AI hardware acceleration intended for either very specific algorithm or more generic algorithm. But in either case, the promise of having a much higher efficiency at lower power compared to other solutions that are out there today and deployed is what excites the investors and others to to focus on these solutions, so we can get more efficiencies coming out of these platforms. So you guys probably know some, but there is probably dozens of companies out there that are building hardware acceleration to handle the workload that is required. So all of these solutions are really good for maybe handling AI in the cloud. We'll talk about the differences. But where form factor, power, and TCO, if you guys are familiar with total cost of ownership when it comes to cloud, is not necessarily an issue, versus getting an application fit and processing is more important. So when it comes to AI in the cloud, the nice thing about it is that it's on demand, so you can really demand the compute, storage, and connectivity that you require, and you can address scale up or scale out very easily, where you need, for example, in a scale up where you have a ton of compute that you require for a specific application, where in a scale out fashion you want to distribute the workload among many processors. So those capabilities are there, so you can take advantage of how you want to implement your AI application in the cloud. The beauty of the cloud is that you can terminate the application and the traffic right in the cloud, where you can point the user or the end customer to that particular endpoint and process the data right in the cloud. It is a pay-as-you-go business model, so it could be actually quite expensive, but it does the job, and established today is based on CPU, GPU. There's FPGAs and starting to see some acceleration cards there, and there will be more and more competing solutions that are going to be trying to address the cloud. And even though it's easily, you can do inference in the cloud, but it's suited for training purposes, but it works for both training and inference. On the other hand, when you come to the edge of the cloud, near edge or the edge, all of a sudden the problem is enormous from one side to the end. You know, you're looking at, for example, a device that is for agriculture that needs to be on a battery for 3 4 months in the field versus a car that's actually running, and very extreme differences between the two end applications. Um, uh,
Hello, hello.
so in AI in on the edge is application dependent, but in some cases, like in autonomous vehicle, they can be actually self-contained and operate autonomously. And in some cases, toward when the car is parked or when the car is at rest, it would actually can communicate back to the cloud for updates and other means. But very different for the edge. The problem with the products on the edge is that eventually they get obsoleted. When new models come in, when you get a camera, you purchase that camera with some level of AI, but then newer version will come in, and it is evolving. That's the critical part. If you need to keep up with the devices on the edge as they're evolving and expanding, and today is predominantly focused on inference or classification, and there's discussion about uh, some level of training and learning that can be introduced. And there's actually a lot of work that's being done, but I don't know if there is mass deployment with in respect to learning and training at the edge. I thought the camera would be a good topic of conversation because literally we're seeing billions of cameras that are being deployed in many different applications, and they vary from very low uh, data rates, 1 to 2 camera feet, which is maybe all the way to vehicle where there's multiple cameras, like in this case 8 to 16 plus lidar and radar and so forth. And as you can see, the level of complexity is um, is enormous. Part of it has to do with the fact that when it comes to camera, uh, since we are mimicking human brain and human intelligence, humans cannot deal with encrypted data. Same for machines. You know, in this case, the data has to be in a raw format. When it comes in a raw format, that means the amount of data that has to be moved is enormous when you're looking at maybe 2K, maybe 4K images, and you multiply that by 16, and you're running at, let's say, 60 miles an hour. So all of a sudden, the amount of data that has to be moved from the camera sensor to the AI engine is enormous. Now, um, you know, the challenge at that point is that can you do some local processing? And this is mainly for opportunity for you guys to think about how do I divide the workload. Do I do maybe local processing for the camera? Maybe I do feature extraction at the camera and then just send the features back to the central processor within the car to process, or just simply send the raw data back to the central engine, central processor. And those decisions have trade-offs to make, and and clearly introduces challenges. Another problem, for example, in this case is that the accuracy, right? In the case of maybe some applications, when it comes to camera, 60% accuracy is sufficient to raise a flag and not a problem. But when it comes, for example, to autonomous vehicle, you want as high accuracy as possible, 99% or higher accuracy, because you want to make sure that you can detect a stop sign and classify a stop sign from a turn sign. Or, you know, if you mistakenly detect a signal, it could, or sign, it could be quite dangerous. That brings the point of, for example, in the case of autonomous vehicle, besides the fact that you have to process the camera, you have to introduce redundancy, right? Redundancy is very, very critical in safety requirements of an automotive application to assure that when you see a stop sign, it is a stop sign. So they duplicate the feeds and assure that the processing is done and there is voting process and other means to assure that the objects that are being classified are classified correctly. So there is a lot of difference. The point I'm trying to make is that when you're trying to make decision on your application, when you're being faced with making those decisions, you have to look at the many different aspects of the workload and the type of workload, the distance that you're dealing with, the resolution, the algorithms that you need to run, the rate that you need to handle, and so forth. So I want to make sure that you guys become aware of that. As I mentioned, it's not one size fit all. In this case, what I'm showing is that the energy source from a target device, and this can be camera or any other device, a sensor device for an AI, but it is actually critical to understand because you cannot of course you can actually do a smart speaker using a server. When you write the application, everything works. But to deploy that, it's just not gonna work because the power requirements are very, very different. Let's go through some of that. For example, when you're looking at USB, a lot of these devices, like cameras, for example, connect through a USB cable to a wall or a source of battery, or a source of energy, and roughly about 3 meters, and you can handle about 2.5 watts total. When it comes to an Ethernet, for example, a power over Ethernet or power over Ethernet plus, you get about 30 meters from the source. And you only can consume no more than 18 watts total. And when it comes to battery, whether it's coin cell, electric vehicle, solar cell, they all come with certain level of limitation. So that means that when you guys are working on defining your algorithm, understanding what algorithms you're going to deploy, and efficiencies of those algorithms, you need to make consideration about the hardware and that you're targeting as well. A typical server, ranges about 800 watts. 16 core, the processor alone in that server is roughly about 150 watts, and it costs you $4,000. So you cannot use this for your smart speaker, right? When it comes to Raspberry Pi, of course, different level of performance, but hey, the platform you get, including the board, everything is roughly 12 watts. You could go higher or lower, depends on what kind of Raspberry Pi. But with a quad core processor there, you're looking at about 2 watts. That's about $55. You can get, of course, cheaper, more. Now, a Raspberry Pi doesn't provide the same level of performance. Again, that depends on the workload and application, but it may be more suitable for the end application that you're looking at. And looking at an IoT device, it could be for agriculture, could be other means. Sometimes it's in fraction of, it's like 10 milliwatts in this case. And it has to cost less than $1. So all of these things, and I'm not even talking about automotive space here, but all of these things range drastically from power consumption, price points, form factor, and then you get challenged with your next AI design. These considerations are critical to look at, right? Now, a little bit more in detail, looking at one of these devices, you're looking at, for example, here, there is a hardware component, there is the software component to our AI platform. The hardware component has certain level of input, in this case, handful of cameras coming in, getting processed, and ultimately will hit the AI engine. And this AI engine could be a simple CPU, GPU, DSP, FPGA, or custom ASIC. And I have other interfaces, Wi-Fi, wired or wireless connectivity, some sort of generic processor and memory that can really handle your hardware platform. On the software side, you know, a Linux operating system is typical in some cases, the framework, library, and application. Now, I can tell you that, for example, in the case of Linux, you're talking about tens or hundreds of megabytes of storage, where an RTOS could be in hundreds of kilobytes. Order of magnitude difference when you're running a Raspberry Pi, for example, with a Linux versus an RTOS. In some cases, you cannot even afford an RTOS, and you may be running bare metal, right? So the footprint for memory is quite important. Um, and the library, right? The library that you, eventually when you do training and you got your coefficients that you need to download into your target application, these coefficients can be floating point, can be an integer. They all make a significant difference when you actually look at your workload and the framework that you're using. And all that impacts your flash, on-chip memory, and on-die memory type of requirements. Another consideration to make is that a lot of cases when you're deciding to choose a platform, I was actually running into this problem at one of the major players where they, do you want to provide third-party access? The moment you allow third-party access, then you have to make sure you have protection for your code, right? If you're developing a code, software code to handle a camera, but then there's a third party that needs to also interface to that platform and add additional, write additional software, that third party access can be problematic, right? Because you need to make sure that you're protected. So that adds additional complexity. And OTA updates is, over-the-air updates is also another critical factor when it comes to the edge, assuring that you're able to provide over-the-air update, for example. On the hardware side, again, as I mentioned earlier, performance, power, and form factor. I was actually dealing with some of the folks in India that were developing platforms based on Raspberry Pi, replacing some of the industrial vision processing. And, they were having difficulty trying to get to the performance levels that they needed to get to, meaning that they were trying to do some quality control on a assembly line, looking at the camera and trying to look for defects in the assembly line. Now the challenge is that depends on how fast the assembly line is moving, how much processing is required, what's the work framework and the algorithm that's necessary to really detect the defect. And they were looking for higher performance Raspberry Pi or actually using multiple of those cards together. Now all of a sudden when you do that, you have to do distributed workload processing and the cost goes up and the complexity goes up. So again, there's those things to consider. When it comes to security, there's another critical factor involved when you deploy products to the field. Your data is either addressed in use or motion. You want to make protect your data and have some sort of root of trust or chain of trust that allows you to establish authentication and assuring that your platform is intended for what it is built. The AI engine, we gotta, if for example someone comes to you and asks you to produce a product and you need to select the silicon or the platform, you really need to look at the what AI engine they offer and what best suits your application. Whether you go with a Qualcomm or TI or a lot of players out there that have they've been there long enough, and there are a lot of startups that provide solution. So you got to look at those engines to see what they how they use this technology, for that matter, and NVIDIA and others. But it is you got to look at the trade-offs and benchmarking for those platforms to assure that you don't select a device that will do the job, run the algorithm, but not meet either the performance, power, or form factor requirements. And at the same time, we want to be able to have headroom. There is a lot of cases where you're building a product and then you need to add additional features or speed up. So making sure there is some level of headroom is critical and important. I thought to take you through, again, since we're talking about cameras, even though ResNet is not the most common deployed algorithm, but it's probably one of the most common for benchmarking. So if you're going to sell your products or position yourself, ResNet is a good model to use for demonstrating how well your application runs. Of course, from that point on, if there is interest, the challenges also increase because it's not just ResNet. There's a lot of other algorithms that are even more complex, more difficult to implement. But ResNet is definitely one algorithm that is used for benchmarking purposes. In this case, we have ResNet 18, 50, 101 as an example. The model has to operate for every classification or the inference for a ResNet 50, for example, roughly about 4 giga operations per second. So the 4 billion operations, am I saying it right? 4 billion operations here that's required to complete the full classification from an input, as you can see here, all the way to the fully connected output of this application. Now, one thing I wanted to highlight, and I'm sure you guys all face this, but it's very important to note, is, for example, it is actually a requirement to optimize for the algorithm once you receive your algorithm. But the challenge that exists is that, for example, in this case, a lot of this convolution for cameras, the input is 8-bit coming in, and the weights are also trained and pruned and optimized for 8-bit integer. But the moment you go through your algorithm, you started to accumulate, and in this case, you're going to see an 16-bit integer, and then since there's accumulation involved, for example, on a 3x3 convolution, then at this point you need a 20-bit result to not lose any rounding truncation issues. And as you go to a higher complex 5x5 or 7x7 type of convolution, then your number of bits increase here proportionally. Now, this is just talking about one of the layers. As you pass through these layers, this accumulation becomes higher and higher, and we started only with an 8-bit input. Now, a lot of folks have techniques and ways to normalize or reduce the number of bits coming in, but ultimately all of these translate into the accuracy that you're looking for producing. So you have to look at the balance here. In some cases, a 75% accuracy is sufficient for many applications. In some other cases, you want to get by far much higher accuracy. So a lot of care has to be placed into optimization techniques, as well as where do you really apply your for example, truncation or rounding in this case. So this is just a few checklists and trade-offs that you gotta recommendation to consider. When it comes to application level, there's a significant difference when it comes to vision and image compared to voice. The complexity of algorithms and the data rates differ drastically. So, and I'm sure you guys know that. So it's important to keep that in mind when you're looking at solving those problems. This, in case of, for example, the input is high definition versus low definition versus audio, and what the data rates that are the signals coming in. Classification accuracy, I couldn't say more about this. It's critical, especially, for example, you have a mission critical application like a drone, maybe industrial application on a factory floor, where its accuracy has to be high, redundancy has to be there, versus a case where when there is best effort. Is there someone at the door or not, and is it friendly or not? And sometimes it's basically an alert is sufficient, and best effort alert is sufficient for those. The other thing is algorithm complexity. Millions of operations to tera operations per second. So that differs from one to the next. I had dealt with a company that came in and introduced to us Binary Connect. I don't know if you guys can look up Binary Connect. I think it's from Carnegie Mellon. So in case of Binary Connect, it's basically either 1 or -1 or 0. So when you multiply, there's no multiplication required when it comes to that. So as a result, multiplication is very expensive. When you implement multiplication, both in area, power, and performance. So if you multiply something by 1, 0, or -1, you literally don't need to multiply because the result is either the value or 0. So it does impact the performance. So my point is that a binary connect algorithm gives you 50+% accuracy. It's not enough to handle any type of mission critical application, but on a microcontroller, very low power, you can actually get high levels of throughput or very low efficiency running. Again, the efficiencies are efficiency and the accuracy of elements, to say, is something you need to consider. Data types, we're trying to go below 8 bits in a lot of cases and trying to come up with algorithms. Binary Connect is actually 2 bits or 1 bit actually. But there's a lot of push into getting these data types to be smaller. At the same time, for, let's say, space and other application, military, FP64, 64-bit floating point is still used. So there are some select areas for those, but trying to reduce the data types and rounding to 8-bit integer is very desirable, and a lot of folks actually do produce products either at that data type or smaller. Another critical factor is throughput. Number of classifications, right? Inference per second at certain batch sizes. Make sure that would be the first question when you're trying to solve a problem is how many classification do you need per second, and what accuracy. Centralized versus distributed processing is another area of importance. Again, there's a lot of innovation, and the reason I'm mentioning these points is that if you guys want to lead in this space, these are some of the out of the box perhaps thinking, do I want to process at the camera head or at the centralized point? And what trade-offs do I need to make, and how do I, what benefits does that bring in? So those trade-offs have to be looked at. Security is, of course, we talked about safety. When it comes to industrial, medical, aviation, ground transportation, all of these require enormous amount of validation and certification, and same for safety, um, that you need to consider. So make sure that you understand those. In many companies, there's actually dedicated security, safety, and other folks that have domain expertise in those areas that are focused to address those. So when you're handling projects in those areas, we need to assure that you're considering all these different standards and classification requirements. Um, and ultimately, at the end of the day, is the form factor. You cannot, you know, have a server on inside a car or attached to a horse, where so that's just not feasible or possible. So power, area, budgets are critical, memory footprint, and ultimately interconnect. So these are some of the checklists and trade-offs. There's many others that's to consider, but these are some. And I think if you go through this, I'm hoping that this brought a lot of questions in your mind, and that in a good way, where as you're going and facing your programs and applications, you'll consider these things and making a note, because that's how you will differentiate your product against your competitor. So focus on application space, understand the platform options, look at your trade-offs. Those are, and I specifically highlighted algorithm efficiencies. That's an area of innovation and continue to be innovation. So whether you use something off the shelf or tweak it for your own use, it's definitely something to consider. And ultimately optimization. I think Bhushan is going to share this slide set with you. So this is not necessarily an eye chart, but it's kind of sharing with you that if you are looking for taking the next step, what skill sets are required. If this slide is provided, you can see for yourself, for example, data scientist and advanced analytics. This is actually where Bhushan's domain expertise come in, so he covers it all. But this is giving a map basically for your domain knowledge and skills mapped against the jobs and so forth that you may be looking for. So what level of understanding you need to gain to address those spaces. So at this point, we reached the end. So I'm open for questions. I don't know, Bhushan, how do you want to handle the questions at this point?
Yeah, so thank you, Majid. If anyone has any questions, please do ask them directly, or you can ask them in the chat room as well. I'll allow participants to unmute themselves if you have any questions from the perspective of AI applications. Actually, we have got one very interesting question. This is from Nandini Sulse. She was asking about what are the real life applications, and she was asking what all things can be done in terms of AI applications. AI is a booming field, it's true, but for students to come into this space, what are the things they should look into? So I would like to answer that question from in a very brief way, talking about in real life application. So whatever Majid just talked about, these are the real life problems that are coming in the app while deploying these applications. You need to take care of your hardware, you need to take care of your power, you need to take care of your model size, model computations, because these are all the things that machine learning and deep learning models are taken into consideration while deployment. So in terms of real life applications, to everyone, at Sentiligent Academy, we are totally focused on creating this real life application. The major motivation for us to start this academy is from the perspective of creating applications oriented, which will help their businesses in their day-to-day life, like businesses for chartered accountants, businesses for dentistry. Actually, we are fortunate to have Mr. Vaibhav Gandhi in this webinar. He is the one who is actually we are working with in terms of dentistry applications. So these are the kind of applications what students should focus on, where it will release or ease the process of the day-to-day mundane work for different people in their different domains. Now it doesn't matter that or you only have to focus on computer vision applications, or you only have to focus on applications where there is a huge amount of data. So in day-to-day activities, in day-to-day businesses, there are different data science skill sets which can be utilized to solve those problems using machine learning and somewhat in terms of deep learning. So I would say that everyone look at the problem from the perspective of how it can be solved and what kind of data is needed to solve that problem. And that's where you can start your journey in machine learning and artificial intelligence, and take care of all those and like take care of those applications in deployment and all those things. It doesn't have to be just an embedded system. It can be a pure software system as well, wherein you can work more precisely to create those end-to-end application pipeline. But do make sure that you understand the entire process of deploying an application in real life, like connecting it to cloud, or bringing the data to your data warehouse or small application warehouse where you're actually deploying those models. So I hope we were able to ask those questions, the solve answer from that perspective about real life applications. If there are any other questions, please do let me know, or me and Majid can solve those questions accordingly. Yeah, there is one question. Can you please explain the difference between data scientist and an AI engineer? Majid, can you take this question?
Sure. You know, data scientists, actually Bhushan, when you look at Bhushan is a data scientist, and he's looking at algorithms and efficiencies of algorithms, implementation, optimization, and all aspects from training all the way down to the inference side. The data scientist also has a good understanding of data sets and how they come together and so forth. When it comes to an AI engineer, again, both of them are broad terms, but I would look at an AI engineer as an individual that is more application centric rather than data centric. In the case of an AI engineer, the person would actually do the implementation of that, what the data scientist will provide. And for example, AI engineer will go to a data scientist and say, I have a problem here. I need to inference on, a factory assembly line to detect defects. And here's my use case. And the data scientist will say, okay, I'll go ahead and implement certain algorithms. And the AI engineer will actually implement on a target hardware. And then we'll come back and say, well, we need to increase the accuracy, for example, or we need to increase the throughput, we need to increase the inference per second, or other means, right? So basically, they go hand in hand, where where they actually can implement a solution. It doesn't mean that AI engineers can't write algorithms, but it's the domain knowledge of a data scientist is where they sit down and solve those problems in the lab, and then the AI engineer will actually implement on a target hardware platform. Bhushan, does that make sense? Or
Yeah. So the major difference what you need to take into consideration being a data scientist and an AI engineer is you need to take into consideration what type of data sets you are using, and whether that data set is biased towards a particular solution, or whether it is like a universal solution that can be created from those particular data sets. So before even starting any kind of problem statement, think about how you can collect the data and then start working on the problem statement. Because if your data is not perfectly aligned towards the solving the problem, then that problem statement it doesn't even make sense, because you are already biased towards one particular solution, which you will get it continuously if the data is not perfect. So that is basically what data scientist typically takes care into. And from an implementation perspective, that's where an AI engineer comes into picture. There is another question: how efficiency, optimization, and security together can be deployed? So I would take this question saying that these three are the basic terms that any AI application deployment should take care of. First thing, in terms of efficiency is basically, as Majid talked about, inference per second. Assuming we are doing, let's assume we are doing image classification. You want to classify 10 different objects in a given image, and then you just wanted to deploy this model in real time. So let's assume a retail analytics as one of the domain, and you want to classify 10 different objects in your shop. So how do you efficiently train your model is very important thing, because model size, if it goes on increasing, then while inferencing, you get a very low FPS, which is frames per second. So that doesn't make sense in real time deployment, because you want immediate actions on those data, or the image feed or the video feed that is coming in. So this is from the perspective of efficiency. Optimization is when that model which you are utilizing, you need to optimize it in terms of the computational power, because if your model is very very big, then again there is a latency, what we call it as like the number of images that can be passed through a model in a given second. The throughput and the latency will decrease in that case. So you need to optimize your model smartly, so that you can actually get a good throughput and less latency. And then third is security. So while you are deploying this application, the security is the major hurdle for all the AI algorithms. So you need to basically take care of, while deploying this application, that you have like it is API integrated, and you have taken all the security measures like GDPR compliances and everything while deploying this application, so that the misuse of these AI applications doesn't take into place. That is what we call it as AI ethics, which is very important. And these are few of the things what I would say we at Sentiligent Academy are taking into consideration, while even giving the training to the students. We are giving the training in such a way that these are the major principles that we follow while making sure that the application is developed.
So I can also add, Bhushan, to the
Yeah.
security part, if that's okay.
Yes.
Yeah. So traditionally, when you look at an edge device, a platform on the edge, you were either concerned about privacy or authentication. Privacy means that you want to protect the device from being viewed, and as a result, you encrypt. Versus authentication is making sure that device is genuine and is deployed for its intended use. So those were what security meant in a lot of ways. A lot of technology was deployed to support both authentication, privacy, or both. But with AI, as Bhushan mentioned, one of the bigger challenges that exists is that impersonation, meaning that ability to fool the AI, to be misled. For example, a doorknob, looking at a camera, when Jim is at the door, it is actually John, for example. So that impersonation, by modifying or fooling the algorithm, can actually externally can cause confusion for the algorithm to either misrepresent or do a wrong inference. And those are quite interesting techniques that have been deployed. So now the security has also evolved to cover other areas like impersonations and so forth. So wanted to add that to it. So it's work in progress in that regards. You can authenticate, we can make it private, but At this point, I think there's a lot of work involved and innovation around protection against um, non-ethical aspects that Bhushan talked about.
Yeah. So there is another question. So I'm a student and I have no experience in programming. How much time will it take for beginners like me to learn? So this is basically this is coming from Shubham. So Shubham, I would suggest you start with Python basics first, as Majid showed in his previous screen about what are the typical things that are needed for an AI engineer, what all care you have to take. It's if you go in sequence, I would say you start from learning Python basics and you slowly move on to data science. Don't directly jump onto deep learning because that kills the total understanding about the process or the journey of becoming a data scientist. So I would say start with data science skill sets, simple machine learning algorithms wherein you can deploy it on tabular data, and then start eventually, depending on the application, jump into deep learning, and then think about what all things you can, how you can explore your models and all those things. So I would say an entire journey of 4 to 6 months would be enough if you dedicatedly work on starting it from today, let's assume. So it 4 to 6 months from today, I think it should be, you should be able to grasp the major technology stack that is there in machine learning and deep learning along with Python programming. I hope that was I was able to answer that one. Then there is another question from Chaitanya. As agriculture is a primary occupation for about half population of India, what are the real life implementations of AI in agriculture? Majid, can you give one or two examples in agriculture as such?
Yeah, so I'm not quite familiar with the deployments of products in that region, but in other parts of the world, um, it is well deployed. For example, combination of wearable and AI deployment with herds that monitor their location and and health status and feed that information back to a centralized location so they can attend to maybe a sick or unhealthy, or they look at, for example, the speed of movement and so forth. Separately, there are other means of uh, field deployment where you're looking at um, lack of watering or over watering, lack of sunlight. That type of sensory information is available to detect and um, provide the feedback back to the yeah, so to back to the, so in that context you're able to correct. So it is, as far as the real-time implementation, those products, in the case of real-time, since, for example, in the case of a sheep or a cow or other cattle, um, there is a device that gets connected to them. These devices normally are asleep for most of the time, and periodically they wake up, sample, and then they transmit the data back to uh, the, the barn for processing. So it has to operate extremely on low power and limited, and sometimes the battery life has to be in 3+ months of operation. I'm not sure if I'm answering the question, but this type of deployment has happened to some extent in some of these agricultural spaces.
All right, thank you. So there are in India. So Majid, just to give you an overview, in India, majority of the farmers who are actually doing agricultural activities, the majority they are doing it with a traditional way. But there is a huge amount of scope that can be taken into consideration from the agricultural perspective. Just to give a brief overview, that what type of crops are being cultivated in what kind of region. So if government takes a survey about all these things, they can easily get an overview about what is the majority products that are coming from different regions. We can do it region wise analysis, you can do at a local level as well, and we can do it at a global level as well. So this kind of analysis is very important, where because of this a sudden increment and decrement in the cultivation or the production of let's assume a simple use cases like onions and tomatoes. So this can be taken, this can be actually controlled in a very easy way if there is a data analytics behind, or analytics that is done behind. So this is a simple use case, I would say, in agriculture. Thank you. There is another question coming out. Is it possible for me to switch in AI if I have an economics background? So I would just answer this in a small terms, a smaller way, saying that economics, if you have a background in economics, that means you have some analytics background, because that is something economics people are taking into consideration. And I would say data analytics, starting with data science and analytics, is a easy way for you to get into an artificial intelligence. Artificial intelligence is a bigger umbrella. So all the applications which are like doing automated analytics is what comes into artificial intelligence. So I would say you have a very good chance of getting into data science, machine learning, eventually into deep learning, in different domains. Taking into consideration, you start with basics of data science, that will help you to start your career in this particular domain. Then there is another question. You did MS in AI ML, right? What aspects did you learn in the academics? Was it from basics and to the expert level? Yes, I started learning from machine learning, and then I eventually landed into deep learning. While I was doing my masters, I actually completed a lot of different projects. My major focus was on projects rather than just approaching to the courses, online courses. So I actually focused on hands-on practice of all these different scenarios. I worked with NVIDIA. I was fortunate to work with Majid in terms of at wave computing to deploy a real life application. So these are the things what comes after you do a practical implementation of these projects, rather than just being theoretical over learning few stuff. The theoretical comes into picture initially, yes, but eventually, unless and until you deploy those application, you don't understand what is the right set of data set that is needed for that particular application, because there is nothing written like that, that this application will need 1 million images, this application will need 2 million images. It's not that way. It totally depends on what complexity the problem is, and what are the things that are, what is the data points and how many feature maps are there in the data points to solve that particular problem. So it's all about practicality. So AI applications can, or if you want to get more into deep learning, only practicality can help to solve all these different problems. Does AI have any web application, the web development? Yes, there are a lot of applications in web development as well. In fact, Emphasis is one of the company which, as I know, that they are actually utilizing AI to create automated websites. So you don't even have to tell anything. You just give your logo and you just tell them these are the particular topics you are interested in. Let's suppose are a Sentiligent Academy. If you want to develop a website of Sentiligent Academy, you just give information about your logo and the basic website will be automatically generated for you. So this is what AI application can do in the backend, because it has learned from all these different websites that these are the kind of material that is needed, or this is what is needed for those application that has to be deployed in on real time in web development. So there are a lot of applications in web development as well. In fact, TensorFlow JS, which is TensorFlow JavaScript, is web-based application which works on your Google Chrome or Mozilla Firefox. Any other questions which we can answer today? I think we are out of questions as of now. So I just wanted everyone to give you a small overview about the boot camps, what we are providing. So we are starting with artificial intelligence boot camps, starting with essential AI, which is a 3 weeks course wherein we are giving overview about what is artificial intelligence, machine learning, and deep learning, and what are the typical applications in real life that you should take into consideration while taking this application. This is very good for students who actually wanted to come into AI domain and wanted to understand what kind of applications you need to work on with your student projects as well, or your graduation projects as well. So this is for those people who wanted to enter into AI and understand how they can utilize AI in their own domain. Then there is a special bootcamp, which is computer vision bootcamp, where we are focusing on retail analytics as of now to do facial sentiment analysis, object detection, and deploy this into real-time system using different amounts of camera feeds as an input, and then analyzing that, and then analyzation in terms of model deployment in deep learning, and also data analytics in machine learning. So both of these are taken into consideration over here. Then there is a foundational AI bootcamp. It is of 3 months. This is a rigorous course. This is as good as one whole semester course for artificial intelligence, where we will be providing the infrastructure to the students, because without infrastructure there is no AI development. And that is one of the thing what we are taking into consideration, that we will be providing infrastructure so that students AI professional can do 24/7 model development, model deployment, whatever they feel wish to work on. We are actually providing a very high end Titan RTX GPUs for model training and deployment. So this is where we will be giving lot of information about artificial intelligence from both machine learning and deep learning aspect. We have few of our instructors over here, which is Bhagwat Chhate, Vinay Gundesa, Mukesh Muthian. These are the people who will be definitely helping into this. They're industry experts. In fact, Majid is also going to be a guest lecturer at some of these uh, boot camps. Then we have another, I would like to emphasize the question which was being asked. What are the real life applications? I would like to say, if you look at the dentistry image over there, this is a real life application where dentists are solving these problems in day to day, and we are actually working with the dentist to collect those images accordingly and to understand, annotate the data, and then try to solve that problem of pathology detection. This is just one simple example which I'm giving. So these are the real life applications. As everyone, your parents are in different domains, so you yourself can utilize AI, machine learning, and deep learning in those all different sectors. So think about a problem statement from the perspective of how you can collect the data. So the real life retail example which I was talking about, if you look at first image, that is what the retail analytics we will be working. It is footfall analysis, customer behavior pattern, customer service, contactless shopping experience, and kiosk management. So these are the things what we are actually looking into. If you have any questions, please do ask us. We have our website for question forum as well. You can contact us on our emails as well. I will be personally replying to all those emails with my experience, and I will be making sure that everyone can deploy their AI applications in real time, because this is a thing what we need to take into consideration while deployment, and also take into consideration while analyzing the data, or training the systems in real life applications. Thank you so much for your time, everyone. I hope we will conclude the meeting if no one has any questions. uh, for the last question is from Nikhil, like fees for the bootcamp. Nikhil, we can contact you from that perspective, we will let you know the fees and everything. We have your email IDs. We will contact you about different bootcamps and their fee structure as well. Thank you.